All right, general math. We are starting chapter 11 today. Probabilities. So here we have a pie chart. Kind of looks like a pie. You can think of it as like pizza slices. And here we have sports. So football's in blue, basketball's in red, badminton is green, hockey's purple, and cricket is yellow. Our first question is how many total kids voted? That's just simply, we just add up all the different fractions. So 2 plus 2 plus 2 plus 1 plus 1. We had 8 voters. How many kids liked cricket? There was one kid that liked cricket according to our graph. And then what was the probability that if you chose a random kid out of these 8, their favorite sport was cricket? You take the number of kids that like cricket divided by the total number of kids. So 1 divided by 8 is 0.125. How many kids voted for badminton? That's in green right here. There was 2 votes for badminton out of 8. So 2 over 8 simplifies to 1/4. You just divide the top and bottom by 2, and that is also 0.25. Here in our next example, we have a spinner, and you're going to have 2 spins. So the first spin could either land on 5, 6, or 7, and the next spin could land on 5, 6, or 7. So your options for all the different spins are going to be 55, 56, 57 if 5 is the first spin. If 6 is the first spin, it could be 65, 66, 67. And if 7 is the first spin, the totals could be 75, 76, or 77. So we have 9 different possibilities right here. And then what's the probability of spinning a number that's in the 50s? So basically, what's the probability of spinning a 5 first, right? Either have 55, 56, or 57. That is 3 out of 9 if you count. If we just count, nope, that's not what we want. Here we have all of our 50s numbers. There's 3 of them out of 9 total. Simplifies to 1 over 3 or 0.33. We are flipping a fair coin. We've done this before. Again, 50% chance because it's a fair coin, either heads or tails. If you flip heads first, again, you flip it again, and it's either heads or tails, and then either heads or tails, right? So if we flip a coin twice, what is the sample space? So that's pretty much like what are the end options, what are the end results that you could get. So if we flip it twice, we're only going to use the first 2 rows, and we could either flip a head or a tail, and then we could either flip a head or a tail, So it could either be head head, or head tail, or tail head, or tail tail. So that's our sample space right there. It's just all the different combinations that we could flip. Another one, what is the probability of flipping less than 2 heads? So less than 2 would be 0 or 1. So what's the probability of flipping either 0 heads or 1 heads? Well, here is our outcomes, and we are flipping all 3 times. Sorry about that. We're flipping a coin 3 times, so how many outcomes have 0 or 1 H's? Nope, nope, nope. Yep, that one only has 1 H, so there's 1. Nope, there's 1 H, there's 1 H, there's no H's. So there's 1, 2, 3, 4 outcomes that could either be 0 or 1 heads. So 4 over 8 or 2 over 4 or 1 over 2, but that is 0.5. Last example here, we have all these different types of cards, and we're playing, I think it's poker. We have royal flushes, straight flushes, 4 of a kind, full house, etc. And so, for example, like 3 of a kind, it doesn't matter what, whether it's like 3 aces or 3 tens or 3 jacks, it doesn't matter, but there are 54,912 different ways to have a 3 of a kind. And then the total number of combinations of card pairs or card orders or hands, I guess, would be over 2 million. right? So if our question is what is the probability of being dealt 4 jacks, that would be a 4 of a kind. So we're going to go to our 4 of a kind, and there are 624 different ways to have a 4 of a kind. So we're going to take that 624 and we're going to divide it by the total, and that's going to be 0.0002401. Pretty much all we're looking for is put all the outcomes, the number of outcomes that you want to get, and divide it by the number of outcomes that are totally possible, right? So it's just a fraction, kind of like what we did up here with our sports pie chart, right? Take your 1 divided by 8, 1 over 8, get your decimal. Down here, take your 624 divided by that 2.5 million and get your decimal. Again, if you have questions, let me know.